Okay, hello everybody. Hope you had a great lunch. And I'm really happy to introduce Danny Dick. He's going to be talking about research experiences and best practices building AIware at JetBrains. So JetBrains is this big company that is behind really powerful IDEs and stuff. Danny has been doing some really great work in the software engineering and education and stuff. So I'm really, really glad to have you here. And the floor is yours. Thank you.
Good. Thanks so much, Gustavo, for that very nice introduction. And I'm so happy to be here. So I'm grateful to Ahmed, to Gopi, Gustavo, everyone in the organizers team. They've done a phenomenal job at preparing this. I said, you simply elevated, you raised the bar so high that good luck with whoever wants to organize an event next so we can get this view. And then the food that we had is like absolutely at the higher standard. And then I'm so grateful for our instructors, like we heard this morning. Very informative, very insightful, very inspiring at the same time. And then last but not least, I want to thank you, the students. Like, look at this weather outside, you know. I just want to go outside and kayak and mountain bike and hike. And if you're not into that stuff like me, into outside, you just stay and watch Netflix. Still, you decide to be here with us, right? And to give us a week of your life, like that shows the kind of people that you are. That shows the kind of people that you love growing yourself professionally and personally. It shows that you want to be in a community with others. So I'm so honored to be in a community with you. So I'm excited. I brought one of my PhD students, Abhiram, which used to be here somewhere. Where did he go? Oh, he was over there. Yeah, you'll see him. You'll see him soon. He's going to meet new friends, make new friends, and hopefully meet some collaborators. And we are so excited to be here with people who are excited about the same topics that we are excited. And today I want to present and take you on a journey on how we've been developing. So this morning we heard about developing software that is also powered by AI. Right, so I'm going to invite you to come with me on a journey, and I will present 3 different projects that we've been building over the last couple of years at JetBrains Research in the area of powering LLM and boosting and rejuvenating and refreshing the way how software developers do refactoring with LLMs. So at the heart of everything that we heard this morning, we keep hearing about LLM is this black box that it's what do you say, Jack? That it's the tool from the aliens that they dropped on planet Earth, and they didn't give us the instruction manual, right? So I'll present some of these lessons as we can like decipher the tool, how to use the tool for the area of refactoring. I will present some of the lessons, some of the mistakes that we made, some of the best practices that we uncovered. We reverse engineered the user manual. Right, and many people also are wondering what's happening with LLMs and with foundation models and what's happening with the ID. Is the LLM going to make the ID obsolete or retire the ID? And I'm here to say that no, it's not an existential threat to the ID. In fact, we are looking at as a LLM as a monkey. It's a really good monkey. It copies what people do and it copies them well. But then, never send the monkey to do a human's job. So in the ID, we have very powerful analysis and very powerful software engineering tools. And that's why I invite you to stay with me and see how, with the spark of the LLM, how do we refresh a lot of the refactoring technology that we have in the IDs. All right. So before we do that, I want to start on a personal example. So this is a typical bicycle ride that I do on the weekends. I've been taking a break from biking because I had a crash 10 years ago where I lost my short-term memory, and actually it was a result of riding a bicycle. So I took a break from biking, except that now that I'm with JetBrains and I'm working from Salt Lake City, from Utah, it's so beautiful out there. I say, well, let me give biking another chance. There's only one problem. It's not flat. So here you're looking at everything. It's flat. Where we live, we are at the base of the mountain, so you can only go up. I guess you can also go down, but we like to take the chair and go up and come down using the gravity. So I said, well, let me try biking again. And this is a summary of my workout. So what you will notice is It's not too much. It's 9 miles, so it's just a few more than 10 kilometers, like 16 kilometers. The elevation gain, look at that one. It's 2,600 feet, right? So it's just like going really over a very short, over 5 miles, just going like thousands of miles up, right? It's just like you go up all the time. There is no flat. There is no. And if you pay attention closely to my body, and if you ate lunch with me, you saw that I love those chocolates. Those dark chocolates were amazing, weren't they? No, I had 2, and I was going to have a 3rd one, and they were all gone. But but if you look at my body from the profile, you see that I have like a nice belly. I don't look like a Lance Armstrong. Like you cannot mistake me for Lance Armstrong. Yet I go up the mountain and I pass all these semi-professional athletes. And how do I do that? Well, I got the proper tool for that. So I got an electric bike, and when I have my electric bike, I have hundreds of watts. I have this Lance Armstrong with me, biking and pushing on the pedals. So now, instead of avoiding the hills, that's why, everything that is flat is boring. I only go on rides where I can go thousands of feet, elevation gain. And it's all fun, right? Because looks like the PowerPoint has a mind on its own, wants to go ahead of me. It's all fun because I have this assistant. I have this electronic version of Lance Armstrong with me, pushing hundreds of watts, and I still got a good workout. Look at my heart rate; it's on average 142, so I can control how much or how little I want assistance, right? So I want to use this same metaphor and see how does this apply to programming? How does it apply to software tools? How does it? And I think the metaphor is the same way how an e-bike, or how automation, or how electrification, or how all these breakthroughs, all these revolutions that we've invented as humans, I think it's the same way how someone, I think Ahmed mentioned, we had like text editors, we had an IDEs. So this is the next generation of assistants where the synergy between the IDE and the spark that comes from large language models and foundation models is really what creates this extraordinary software developer. So we presented this work at ICSME just a couple of weeks, 3 weeks, 4 weeks ago in Arizona. And this is the paper, so you can get the QR code. It's an amazing list of collaborators. And this is the tool extract method assist that supports developers to to refactor their code. Just before we talk about extract method assist, how many people here, I'm just curious, raise your hand if you've done any refactoring on your code in the last month? So I see that about half of you. So the people who refactored their code last month, can we get like a couple of examples? Like what refactorings have you done? So I saw that you raised a hand.
Like it's mostly when I started to write my code, I had like a lot of testing involved, compilation of the projects and stuff, and it was really hard to understand. So I had to make like I had to make like a repository class, let's say, and then it was supposed to handle all the compilation and stuff, and then testing, and then if there's a prompt part involved, so I had another class called prompt. And
Yeah. So you started with the monolithic code that you separate, you cleaned up, you modularized this. That's a great. What's another example? Somebody else who gave a? Okay, so over here.
Move up method, move class, move attributes.
So you move some classes, okay? Attributes, yeah.
Packages.
Right. Excellent.
Some shape to the code, improving the design.
I love that. One more. Let's see one more. What's another example of refactors that people have done on the code? Michael.
So this was for a class. I was designing a student assignment, so totally greenfield. And the way I typically do this is I have a vague idea of what I want to do. I build this thing, and then it sort of reveals itself to me what's interesting about this and what's too hard, what's easy. But I have to keep changing my mind, keep moving things around as the abstraction makes itself concrete in a very platonic sort of way.
Yeah, so you started with the vague idea, like what I'm hearing, you start with the vague idea, and then you just let the code come out, and then we'll restructure, move things around, clean them up. So those are great examples of refactorings. I noticed that not every single one of you raised their hand, so I suspect that the people who didn't raise their hand didn't write any code last month. So, but long methods. So we heard about long methods. So long methods, you see them everywhere in code. So they are bad, right? They are just grown over their normal size. They often perform multiple tasks. They often do too much, right? They are considered an anti-pattern in software engineering. Bad code. Some problems, right? We all know they reduce readability. They reduce the reuse of code, the modularity of the code, right? They are producing higher maintenance cost, decreased usability. All of this stuff, like bad. Don't do that, right? That's a source of technical debt. So we all have seen, I've written this code, and I've read a lot more code like this that was very long. So the well-known solution to clean it up is extract method refactoring. So in this, you select a portion of the code, right, and invoke the IDE to create another, to extract that code fragment into a new method, right? And then we replace all these lines with the call to the new method. So those are the three steps, right? And this is well supported. It's done in all the major IDEs. Of course, IntelliJ has very good support for extract method, right? Unfortunately, despite the fact that it's probably maybe one of the first 3-4 refactorings that was implemented in IntelliJ, and it's also one of the top 5 most common performing in practice, it's kind of like it's been the same for the last 20 years. You know, since IntelliJ came out in 2001, it's the same workflow. It's the same. It does the same thing. Sure, it's better, it's smarter, it's less buggy than it was 20 years ago, but it's kind of like the same thing, right? So you notice here that it's semi-automated, so developer still has to select the code fragment, and then the IDE doesn't provide any recommendations, right? So it probably gives you a name. It suggests a name, a very simplistic name. It just say extracted the code. It's called it extracted. That's what it suggests. So there's a lot of research on the recommendation side, and here it's a lot of papers, a lot of tools that have been focusing on this problem. So JDeodorant is probably one of the most famous ones, and it's actually made here in Canada, so yay, go Canada. JExtract, LiveRef, RAMS, GEM, Semi, and the list goes on and on. Essentially, all of them work by doing the same thing. They optimize some software quality metrics. They are looking at cohesion, coupling, and they are trying to move code or split code based on how they can optimize those software quality metrics. Unfortunately, this doesn't allow with how developers prefer to use these tools in practice and how developers think about code. Why? Because developers not only use, show me a developer that kind of like it's so obsessed and measures all the time. No, they use their common sense. They use their common understanding of programming abstractions to figure out what makes a good programming abstraction. So just optimizing software quality metrics is not aligning with developers' preferences. So the idea was, our intuition was, well, these LLMs have been trained on billions of functions, of code functions, on methods, right? So they know what are the code fragments, the code statements that make good abstractions. So very likely they are going, it's just, as I say, it's a monkey, it's going to imitate human behavior. So very likely that they will probably do a good job at suggesting which code fragments belong together and should form other functions based on its humongous large training data sets. So in fact, our experiments with replicating more than 2,800 real-world extract method refactorings show that indeed they are very capable. So they give, on average, 4 suggestions per method, and these are actually good suggestions. However, the dark side, so here we've been hearing all this morning about, wait for it, it's coming. And see Jack is smiling. So there's a lot of hallucinations. So what you see, what I showed 4, it's 4 good suggestions. But to get to these 4 good suggestions, there's about 45% of the suggestions that they give you are invalid, potentially resulting code doesn't compile or is wrong. So LLM will say, start extracting from here, from the middle of this for loop, and then go to another, outside of the for loop, go and extract in the middle of another while loop or something. It's illegal. You can't even extract code like that you break the boundaries of the code, right? In the LLM's mind, it makes together those fragments, those code tokens co-occur together. That's why it recommends them. But it's illegal. You can't even do that. You can't even refactor the code that way, right? Or it gives you about 16% of the suggestions are just no-go from the beginning. You say, well, extract the whole body of the method or extract one line. So the key idea, how can we harness this spark that the LLM has seen code fragments and code tokens and AST program elements that go together, but at the same time, how can we get rid of all these hallucinations, of all this garbage that the LLM recommends? So how can we use using the ID actually to filter out all the junk and to safely execute the refactoring? So this is our solution, EM Assist. It's a tool which combines the creative capability, the spark of the LLM, plus a bunch of static analysis that we have underneath to filter all this hallucination, to enhance the LLM suggestions, right, to rank them, to provide them to the humans. So we provide a short list of highly curated recommendations, which is what an expert programmer will probably recommend on your code. And then we execute them safely with the IDE. Right, so utilize all the raw full power of the IDE. There's a lot of thousands and thousands of lines of code of static analysis that check that refactoring is safe. So before I talk more about this, let's see how this works in practice. So Abhiram, come here and show us how it works.
Yep. So excited to be here. Let's see if this demo works. Fine. Does it? Oh, okay. Yeah. So here's like a long method that you probably want to split up because there are too many lines of code. And this is how our tool works. You click on the method and you ask for extract method suggestions. And in the background, this goes to the LLM and a few times, and it comes back with some ways to split up this code. And here's one of them. It says everything in this green highlight needs to go into a new method, and we call that handle measurement data, and that method would be 14 lines of code long. And if you like this suggestion and you actually want to execute it, you click this button, and boom, just like that, you get a new method. You can try this on some other pieces of code too. So here's another method which is kind of long, and you click a couple of buttons and it will give you some suggestions about how to split it up. So here there are 3 ways that the LLM is suggesting us. So go here, or this other block of code. And the human is in the loop. So here you can look at all of them and see which one aligns with what you like. And then if you like any of them, you can actually carry them out.
All right, thank you.
Present it.
Yeah. Thanks, Abhiram. So yeah, the demos. All right, so just underneath what's the flow, how we incorporated an LLM in the workflow of an IDE. So we start from the developer selecting, right? We get what's the method to refactor, right? This is where we are sending everything to the LLM. In this case, we are using GPT 3.5. It just works. It's the cheapest, and it works really well, right? I'll talk later about what's the secret sauce in the prompt, because if you just send the code and ask it for a recommendation, it's going to produce lots of garbage. We do it several times, and this might seem like waste, but it actually is not. It's one of the secret sauces. We get extractment of suggestions from the LLM. As I said, we enhance them. We filter out a lot of 60-70% of them that are hallucinations, right? And this is where we use the raw power of IntelliJ, all the refactoring analysis preconditions underneath, right? Then we come back with a ranked list of valid, useful suggestions. We show them to the user, and the user finally selects which is the one that they like, and IntelliJ on behalf executes this workflow. All right, so how does this? How well do people like this? So we replicated about close to 1772 or close to 1800 actual refactorings that open source developers performed, and we used our tool EM Assist to see can it match line for line the recommendation, exactly the same code fragment that the developers perform, and in half of the cases we can match line by line. In comparison, the best state-of-the-art, the best-in-class static analysis tool, and then also compare with deep learning tools, have a much lower recall, 39 and 5%. We've also done a user study with 18 professional software engineers at JetBrains that were using, looking and analyzing at suggestions on their code, and they agree with 94% of the recommendations coming from our EM Assist tool. Right, and this is what I like about their responses. Thank you, I hope to see this in production. But this last one I really like. These suggestions made me look into the code with a fresh new set of eyes. So we just changed their lenses and use a different kind of lens and saw something else in the code with these new lenses. And they really liked and they refactored the code that way. Okay, so let's switch to another one. And I'm going to invite again Abhiram, since he's the student who worked on this. And Abhiram, tell us about another second refactoring. It's where we use large language models to perform move method refactoring, which is a much more complex refactoring than the first one. And Abhiram will tell us why.
Yeah, so move method is a little more complicated than extract method because you don't really, you have to care about more than just a single file of information. You have to look at kind of the whole project, and if the method is out of place, you want to find the right place to move it to. So move method solves this problem of feature envy, where this particular method is more envious of the guy drinking the drinks on the other side near the pool. And really what this particular method is doing is it's calling the objects from another class, and it's calling functions or using attributes from another class more than it is of its own. So that's why it needs to move into another place. And doing this requires some kind of understanding of more than just a single file. And that's why it's a little more complicated than extract method. So like I said, determining which method is out of place is challenging, and also finding a suitable target class is difficult. To do this, we used the LLM. We used some vector embeddings of the method themselves and computed some kind of similarity scores. And on top of all this, we always use the IDE to validate and double check. Are we doing things correctly? Does this break the code, or is the refactoring going to be correct? So here's another demo of what it looks like for move method. So you start with the class.
So we need to stop the presentation because it's still showing the presentation.
Oops, okay.
Yep.
Okay. So you start with the class again, and this time you want to analyze the whole class. So you click a few buttons and ask for move method suggestions. And then it comes back to you saying, hey, this method is out of place. This particular function, it's calling only this parameters of fields and function methods. So you can move it. And it also gives you some kind of rationale and some reasoning for why you should do this. Blah, blah, blah. Method directly interacts with this other class, so you should move it there. And if you like this suggestion, you click this button again. And this takes you through the exact workflow inside IntelliJ. So you can preview the refactoring. You can see what files are being changed. And finally, you like everything, you can execute it, and that moves the code around. So that's our move method tool. We call this Assist.
All right.
Presenter view. And here's how it works internally.
Yep.
You give it takes a Java class, and it figures out what methods are out of place. by performing some similarity analysis based on vector embeddings. Then it uses the LLM to prioritize which ones are really out of place. So this is like using the LLM to kind of rank them and figure out which methods really need to move. Then we use the IDE-based tools to figure out which classes are appropriate to move them into. And finally, we display these suggestions to the user in that pop-up window that you saw. We evaluated this by building a corpus of 200 refactorings in open source projects. These were move methods performed by real developers, and we were able to get a recall of 80%, which is 4 times better than previous best tools.
All right, thanks so much, Abhiram. So if you want to make sure that your demo works, when you give talks and presentations, just you can get Abhiram with you. So 100% guarantee the demo works. Good. So I'm looking at the time. How much time do I have, Ahmed?
A little bit more than
15 minutes. So he just gave me half an hour. Okay. No. Okay, 15 minutes. So probably I'm going to shift gears here. So this is a paper that we presented at FSC last July, and I will not have time to actually work, but this is essentially the idea. It's how can we use programming by example. So here is a common change pattern that developers do. So they change this for loop iteration that iterates over a collection and computes its sum and replace with numpy that sum, which is a lot more efficient. It's performant, right? It uses all the vectorization, all the hardware accelerators, and everything that the library is optimized to do. Right, so this change occurred in hundreds and hundreds of places in open source. Even in the same project, it appears several times. So the idea is, how can we learn this repetitive change that we see over and over in code bases, right? And how can translate this at other code locations, other code sites? So that's the idea of the programming by example or transformation by example. The main culprit is that unless your code looks exactly like the place from where you learned from, you cannot, this transformation by example is very fragile. So that's where we use this LLM to say, how can we generate many code variants, all the code variants that the LLM can generate of a given code snapshot, of a given coding idiom. And then we learn and synthesize the protein transformation rule from those examples, right? And then we can cover a lot more variants. So we presented this. This is our 14x. So this is not a typo. It's not 14%, 14 times, 1,400% improvement. And I'm going to skip the workflow, how we use it to generate code. And actually, we also use it to generate test cases to test that transformation it's done correctly. Let me share some of the things that we've learned as we decipher what you call the aliens dropped, like the aliens drop the black box. So some of the lessons that we learned: trust but verify. So LLMs are prolific for refactoring. So we showed here 3 different ways how we harness their creativity, yet it comes at a super high rate of hallucination. 73% for extract method, 80% for move method, PyCraft, 65%, generated used unit test. These are again small coding fragments, 35% rate hallucination. So the key is to, essentially like when you go to the doctor, like the doctor tells you, eat healthy, sleep well, do all this stuff, but they don't do those, right? So it's the same thing. Do what the LLM tells you, but don't let the LLM touch your code. So in this case, you need to use more powerful validators. The one that we use automatically are refactoring preconditions in the IDE. So that's where we use all this huge raw muscle power that the IDE has to discard a lot of the junk. And I'm posing this question: what are some other ways? What are some other problems where you can use all these really powerful analysis tools from the IDEs or from static analysis tools or from other tools that you can use to discard LLM hallucinations automatically? We design new static analyses to eliminate, and also we use dynamic. We use tests. So I mentioned in the example of PyCraft, I didn't go too much in details about that one. We actually generate small test cases to check that the transformation is correct. So we heard about prompt engineering and the black art of prompt engineering. So indeed, it's actually a black art. So for us, what we discover is the more precise you are with the prompt, the much better you can focus. You can focus the laser towards getting high quality suggestion. In our prompt, we even have to be so precise to even put like specific line numbers and refer to the code to the line numbers. And then we had the big breakthrough when actually one of my colleagues at JetBrains, Igor, suggested that we even ask the LLM to give the recommendations in a certain JSON format so that it can be processed by other tools, right, using this structural format. We experimented with all kinds of prompts. Few-shot learning worked the best for us, both for EM Assist and PyCraft, so we give 2 to 3 examples. For Move Method Assist, which is the most complex, we use both RAG to focus, like in that case, the search space, especially if you're moving a static method, you can move in a project like Elasticsearch that has 21,000 classes. It's fair game. You can move a static method in any other of these classes. So you have to use an approach like RAG. You cannot send the whole code of the project to the LLM. We also use chain of thought reasoning. So this is how you attain the LLM non-determinism. So to get consistent high quality consistently, you need to reprompt. So everything that we learn about in programming and in computing, like we learn about that, that's why we use like caching and all of these things, because we want to avoid wasting compute cycles. Here, reprompting and asking the same prompt several times and then aggregating all the solutions and then ranking them actually is not a waste. You must do that. Otherwise, you get very non-deterministic results. Sometimes you don't get any results. Sometimes you get only junk. So that was one of the key. And then sweet spots, so these hyperparameters that you can tune. So LLMs have these parameters. You get the temperature, it controls the creativity, right? So if you have a good validator, like in our case, we have this very strong, powerful validator from the IDE, we can let the LLM be more creative. So we can turn on all the way to 10 the creativity, because we can discard automatically a lot of junk. If you don't have a way to automatically discard the junk, then you need to turn down creativity and let the LLM be more conservative. So playing with that and finding what's the sweet spot, how many times you prompt, and what's the right level of this hyperparameter, the temperature, the control creativity, it's quite essential to get best results. All right, so in the executive summary, so we are witnessing these seismic changes in the landscape of software development tools. I have shown 3 examples of how we've been harnessing the raw power of the IDE and also the spark of the LLM to refresh and to rejuvenate and to come up with a new generation of refactoring tools. So the key was to use the IDE to validate a lot of, up to 80% of the suggestions that are hallucinations, right? So in the end, I want you to remember that LLM is a monkey. It's really good at remembering and copying and doing things that I've seen the humans do, right? But then you need, as I said, you cannot let a monkey do a human's job. You need to have something much more powerful in software development tools to come and filter out a lot of those hallucinations. So we say that the sum of this part, the human in the loop plus the IDE plus the generative AI, is greater than any of these components on their own. And I think this is truly how we are going to, I think Ahmed was saying and other people are saying, how can we turn regular programmers into superhuman programmers? How can we go from millions of software developers to billions of software makers? So I will be really happy to answer some questions. And of course, we are here for the rest of the week. And we would love to talk with you, get your ideas, what's something that resonates with you. If you're interested to work with us and collaborate with us on this kind of work, come and talk with us, and together we can go a lot further than any of us can go in isolation. So I see hands raising up here. So 1, 2, 3, 4.
So let's just clap for the presentation. Awesome, very inspiring presentation. Just a few quick comments, right, before we get to the question. So one, this is an amazing example of an FMware, right, where you have LLM components, but you also have the traditional codeware components like the static analysis and so on, right? And for those who are not familiar, so JetBrains is behind IntelliJ, which has, super popular in the Java space, and in the mobile development ecosystem as well. So the Android Studio is fork essentially of
It's IntelliJ.
Yeah, it's IntelliJ. So this is what 95% of the world use to develop Android systems, and it's not different for Huawei. Interestingly, Huawei has Dev Echo, which is also basically a fork of the same idea. So yep, amazing. So who has questions?
Yeah, who wants to go first?
Yep.
We'll see. Hands going up.
I'll go with the lady first. Oh, not you. Okay, sorry, you. I thought you had a question. Sorry.
Okay, so I'm gonna flash back to 2018, 2017. IntelliJ was in the market, and they had that right-click refactor, and it was a static right-click refactor rename, and search through all the syntax tree and rename all the variables. It was a static. Again, extracting method was a static as well. It was part of code was just copied, create a method, you give a name.
Mm-hmm.
And if I was a developer and I was tired, I had 100% trust in the IDE. I was like doing the right-click refactor, done. But now with the LLM, this two parts, getting rid of the parts that are hallucinating, you said getting rid of the junks, and also testing the code, which I think it's not possible without test cases, complete test cases, I'd say. So how do you give the developer, which is using this IDE, this 100% trust like before?
So that's a phenomenal question. Like, so people expect from a compiler, like, a compiler, you never look to see what's the assembly or what's right. You like fully trust, right? And if you think about a tool like an IDE, also people have a high level of expectations. You cannot break the code. So that's why just taking the raw LLM and just putting a thin vanilla layer of an IDE, nice user interface polish over the raw answer from the LLM, it's a no-go. People are not going to trust and accept that, right? So I just showed here one of the examples of there's a lot more work that we have to do to increase people's trust in the solutions that are, the suggestions that are coming from the LLM. So I think that's the way to go. It's not a compiler, IDE is not a compiler, right? So it's always an interactive component, it's always a human in the loop. I mean, the human presses that refactor button that Abhiram showed, like the LLM doesn't press the button, like the human presses that button, right? How can we move beyond that? Can we move into an agentic way where actually a foundation model actually presses that button? And yes, we are working in that, but we are not there yet.
So yeah, because I was seeing some code, the developers were made those code, and it was refactoring by developers. It was not by AI. A lot of them were causing problems to the code, not just failing the test cases, deeper architectural problems to the code. Yeah. So if developers that are aware of the code are making mistakes here, the LLM that is hallucinating, and developers can just see and say, okay, just okay.
Yeah,
This is, I think it's a little bit challenging for the future work, but yeah, thank you for the answer.
But also it's called job security.
Yeah, yeah.
So I'm looking at every, Einstein said that in every problem hides the seed of an opportunity, right? So that's a problem, and that's why all of us, look how many fresh PhD students we have here that have all are excited and have energy, right? So that's the kind of stuff that will get, how many PhD dissertations that can write, and how much super creative work people can create. So that's why we are here together. Wonderful. Okay, let's get another question from the back. So I see a couple of people there.
So Danny, it's great that you did a lot of static analysis that's present in the IDE to do this. But one of the limitations of static analysis is that it'll only analyze one programming language. And one of the advantages of LLMs or LLM-based tools is that it's language agnostic, right? So do you see a future where, there's still no cross-language, production-level cross-language static analysis tool doesn't exist, right? It doesn't exist in JetBrains, it doesn't exist anywhere. It still analyzes only language by language, right? Yep. So, and applications are multi-language. So do you think that we need to be going back and doing research in static analysis to improve that, and LLMs are good as they are?
So that's a wonderful question, right? So it's how can we how can we make, that's the beauty of the LLM. It doesn't care about, you throw it C#, C++, Java, Python is going to chew it. I mean, you can throw it some, funky language that has never seen exemplars, so they will not do a good job. But, if you give it like the big ones, right, it's fairly reasonable, right? The static analysis tools, the power that they have are all because they require a lot of semantic analysis, so they are not just simply parsing the program using after syntax trees, but also build much more powerful dependence graphs and other programming abstractions, right? So you get these opposite two different worlds. So there are some people that I know have been making efforts to make this static analysis multilingual. There's another approach, and the success has been varied. So in some areas better success than in others. There is another approach where actually, if you think about an LLM as an agent that can invoke all this. So we have refactoring and static analysis for Python. We have for Java, for C#, for C++, for stuff that processes XML configuration files, right? So instead of making one that understands every one, it's actually going and calling the tools, the proper tools for the proper job. So it's also essentially having like a tool chain around you. And from the LLM it can process any language, but then an agent is going to call the right tool for the right job. So that's another approach that people are thinking, and I think in the short term or probably in the medium term it has more chance. Right. So I think there was a lady over there in the back, and then someone here.
Can we take this?
Or over here? Yeah.
Thank you.
You were the first one. Sorry, you're the first one. Thank you,
thank
sir.
you.
You've been patiently waiting.
Thank you for the presentation. I have two questions.
Sure.
What does refactoring mean for AI agents? Do they care? The second question is, what are the roles of IDE for agent-based software engineers? Do agent-based software engineers care about IDE? I know JetBrains creates great IDEs for human beings, right? But what's the point of IDE for agents?
Right.
Thank you.
Very wonderful question. So I would love to answer those questions if we had a glass of water or something else other than water. That's the kind of discussion that we could go on for hours. Just a couple of things. Yes, JetBrains has built I would say the greatest probably programming environments for humans. We are also building them for agents. So some of the work that I'm going to present tomorrow, when I'll give an overview about the other work that is happening at JetBrains, I will mention that. And then you were asking about, so that was the second part. What was the first question? Yes. So does it like if the code, if the code is manipulated by AI agents, do we even care about refactoring in that case, right? If the code, like I'm trying to, if this is where you're going, like if the code is generated and it's not written by humans, like why do we even care about refactoring? Is that the question? Or
yes.
Or, yeah. So that's refactoring has several purposes. So most people think about these renames and extract. A lot of more sophisticated refactorings have to do with performance optimizations, have to do with parallelism of code, have to do with, so there's a lot of space for code optimizations, code improvements that even code that is not written by humans and it's generated automatically by agents will have to go through that. I will have my student in one of the lightning talks this evening. Actually, that's the project that he works on, and I would love for him and you to have a more longer conversation, because that's exactly the kind of questions that he's asking himself.
Thank you.
Wonderful questions.
Yeah, thanks, Danny, for the wonderful talk. So I have a question regarding the type of suggestion the large language model kind of gives for refactoring, right? So you mentioned you use GPT, which is a very kind of general purpose large language models, but we know kind of refactoring or program comprehension is very project specific or very code specific, right? Do you think, is it worthwhile maybe try a smaller model but more fine-tuned with localized edits and suggestion would help things, or you think it will actually go to a more kind of bigger, but with lots of different kind of scenario, lots of example building? Like which one you think would likely be the future?
So Jack, thanks. That's a great, like we never pitted, we pitted several large language models against each other, like GPT-3, 4, and 5 against 4 against the ones from Google. So I can give you an answer on that. We never pitted this against a code T5 or something that was specifically trained just for code. What we were surprised is even a model like this, like GPT model, which was not trained specifically for code. Again, it ingurgitated, lots of code, but it also has all the textbooks on software engineering and design principles and everything else, right? So we were surprised that actually it works so well. So far we haven't seen a compelling, like again, with the ones that we have worked with, we haven't seen a compelling reason to move to the models that are trained specifically for code. Are we willing and experimental? Yes, that's also, it's on our pipeline to experiment and see if we get like smaller rates of hallucinations, if we get higher quality of suggestions, if they align even better with the refactorings that humans actually did in open source. So those are all open-ended questions and a very active area that we are interested in.
Any other questions?
There's one in the back.
All right, thanks for the inspiring talk. So I do have a question regarding the, for the refactoring. If you look at what the a larger number of requirements from industries, people wanted to do refactoring at a architecture level. For example, you're using bridge design pattern to implement the features, but it may be not efficient, and you want to switch it to adaptive pattern. So what do you see the role of LLM in those architecture level refactoring?
Mm-hmm. That's a great question. Again, what I've shown is more like the lower level building blocks with extract method and moving method and stuff like that. How are we moving up on the hierarchy from these lower level building blocks to architectural level, design pattern and architectural level? So it's something that we want to explore. I don't have, unfortunately, as of now, I don't have any answer, but in the agentic approach that we are working on next, that's the kind of refactorings that we want to tackle. Those actually that involve changing, re-architecting a software, or yeah. I think if we speak again in a year or two, probably it might take us more than a year or two, I would imagine, and then you'll have to wait for Abiram's PhD dissertation to be written. But we will make progress. I guarantee they will make progress on that line. I don't have the answer for you today now.
Okay, I'll do like a final quick question.
Sure.
So in your approach, you mentioned the need to reprompt, right? Which means more inferences.
Mm-hmm.
So can you comment a little bit about the cost of running your plugin?
Yeah, what's the cost? It's in the sense, because that's why we are using like even 3.5 or GPT-4o. So the cheapest of the model, we are not using the super most expensive, or even the simplest ones perform really well, simply because we can eliminate hallucinations. Of course, the more expensive ones will perform even better, but at 10 times the cost. So
right.
what I'm trying to remember, Abiram, do you know on top of your head, like we computed somewhere, because people were asking us what's the cost. It comes to
it was
1
something
cent,
like
2
10
cents?
cents per
10 cents per
for a single function. Since we're sending a false function, it's like 10 to 20 lines of code.
Okay.
It's not that expensive to reprompt. But for move method, it's much larger context, and in that
Right.
case, we have more deterministic components, and we aren't sending so many prompts there.
Gotcha. Okay.
Yeah, so that's one of the things. Yeah, that's why we don't send huge amount of.
Right.
We don't dump files and files and files.
Right.
We
Makes sense.
do as much as we can internally, so that we can what we show to the LLM. It's fewer tokens, and we don't incur a huge cost. This is not free. We've been also experimenting. Speaking about experimenting with Ollama. So Ollama, it's an interface
Local models.
and runs local in your machine, and it's fully open source.
Yep.
So we've also been experimenting with that.
I would
and
love to
also-
have that.
Also works. Yeah, works quite well.
So, thanks, Danny. That was a very engaging talk. We have a question from an online participant, Haibao
Hi,
Wang.
people.
So they're asking, so the extract method suggestions of LLM could potentially change the behavior of the code too, right? When it's proposing potential candidates, and how does how are you catching this, or what is the side effects, and what are other flow analysis that you guys are engaging in?
So I answered that at a deeper level, which I'm not sure whether this participant is asking that. So there are extract method is a very well studied and very robust implementation. It's one of the first ones that has been in production for more than 20 years. So it's quite fairly robust. So yes, there's still probably bugs. Yes. Show me a piece of code that is bug free. So I will not stake my life claim against that. So yes, there are still probably bugs, but by now, after millions and tens of millions of people have used that, there are some scenarios where when you have very tricky semantics of the programming language, where the fact that you call this method before or after something else, another computation, especially when you have asynchronous or lambda expressions or streams, that can introduce some slide semantics. So I'm not sure if the person is asking about that. In regard to LLM, is absolutely he's spot on, or they are spot on. Like that's why I say this 80% rate of hallucination. If you take the output of the LLM, if you run this to an LLM, you get the output, and you manually extract the code how the LLM says, guaranteed 4 out of 5 cases that the code will not compile, will crash, will not, right, so that's why we don't use that. That's why we use this. We take the LLM suggestions and we sanitize, and then what we show to the user, it's a small number of suggestions that are all safely executed with IDE. Now, this is correct, modulo the bugs in the IDE, and I said, it's been fairly well tested and fairly robust. Great question, and yeah, people online, we appreciate you. We love that you are joining us from all over the world.
Okay, thanks very much for the awesome presentation. Thank you, Dan.
Thank you for asking all questions.